What is Industrial Revolution 4.0? The term Industrial Revolution 4.0 is referring to a latest degree of operation and control across the whole value chain, include the lifespan of the product. It is a new degree of organization, a control across the entire value chain, and it is a product life cycle. What is facility management? The facility management is the practice of preserving a facility original expected asset value by improving and maintaining the quality achieved during the design and construction stages. It is most time-consuming element of a building's life cycle. It is integrated initiative to manage, maintaining, and modifying organizational building and infrastructure. Next is the attribute of IR 4.0 and facility management. First, Industrial Internet of Things, which is IIoT. Second, augmented reality. Third, the cloud. Fourth, cybersecurity. Fifth, big data and analytics. Sixth, autonomous robots. Seven is artificial intelligence, which is AI. Eight is horizontal and vertical system integration. Here are the advantages of Industrial Revolution 4.0. First, higher quality goods and services. Second, enhancing lives in general. Third, competitive benefit over rival. Fourth, market expansion and new market development. Fifth is improved operational effectiveness. Here are the disadvantages of IR 4.0. First, high cost. Second, high rate of failure. Third, cybersecurity. Fourth, need for highly skilled laborers. Fifth, industry and market disruption. Here are the disadvantages of IR 4.0. First, high cost. Second, high rate of failure. Third, cybersecurity. Fourth, need for highly skilled laborers. Fifth, industry and market disruption.
Hello, my name is Noshairah binti Abdul Wahab. So I'm gonna talk about case study for this assignment. So this case study illustrates the application of the facility management and the proposed methodology to a mechanical company in the manufacturing industry. In an effort to enhance facility management activities via the use of CPPS and IIoT technologies. The ASIS scenario is shown first, then the 2B scenario, which shows how the CPPS and methodology will be used. Hello, my name is Noshairah. So let's continue with these organizational structures. Okay, the organizational structure of the production company that shown, which manufactures molds for automotive, electrosanitary, and household appliances, is divided into administrative, and production functions. Accounting and financial, personnel, sellers, safety, and quality functions are staffed and organized administratively by the company management. The production department oversees the design, production, warehouse, and maintenance processes. The company has two production facilities, one centrally positioned to produce small and medium-sized mechanical molds, and the other decentralized to produce huge molds.
Hi, my name is Nurdania binti Heri, and now during the implementation of the Smart Industry 4.0 project, SDAM is choose to modify its organizational structure by incorporating a new facility management OU. The step-by-step technique for facility management described in the section titled The Methodology for Facility Maintenance Management was executed based on two phases, which is planning time and operating time. First is the planning time. A. Focus on the area of intervention and identify the roles to be assigned. The application developed for the management of maintenance activities focus on the area of intervention, which is organizational unit, work center, and work unit, and the type of the intervention, which is electrical, electronic, hydraulic, and mechanical, based on the type of machine or asset to be maintained. B. Select the management approaches for the region of intervention. The machine under consideration in this case study was maintained on a periodic basis, as such as followed a time-based maintenance strategy. C. A clear and in-depth understanding of the suitable technologies for the object of system to be maintained, which is two sensors for detecting temperature and vibration have been installed on the machine. Last but not least, D. Plan the management activities for the project for the object or system. The gathered information enable decision-making procedure aimed at preventing future difficulties, such as the potential of pre- or post-production maintenance to eliminate the need to halt production for a longer period due to avoidable errors. Next, I will continue to availability time. E. Implement management support hardware and software system and big data technologies and technique to support the management, planning, and recording of the execution of preventive and corrective maintenance activities of the machine. Next is F. Carry out the maintenance tasks. And then G. Process feedback. Once the maintenance activity has been completed, the maintainer must engage in a feedback process through the same system that enables ongoing development of the maintenance planning and operating process, which directly impacts the planner function.
Okay, so let's continue with the last slide for case study. The table shows the summary of the main results evidence after the introduction of the new maintenance system in comparison with the previous year, which is before the intervention and after the interventions. For downtime, it increased 27%. For breakdown, it increased 45%. Production of capacity, it increased 25%. Production output increased for 12%. And maintenance cost increased for 20%. So overall, there's a lot of increase after the interventions. A lot of improvement after the intervention. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurlaila binti Alipuddin, and today I'm going to present about the recommendation for improvement. Smart facility management is a technology solution that gives facility manager the tools and insight needed to tailor the environment based on the needs of employees, customer, occupant, or company expectation. Smart facility management can positively impact both people and process, create change, support data-driven decision, and improve result. Smart facility management is about using technology as a means to an end and being better for it. Smart facility management, which is FM, refers to the integration of system, process, technology, and personnel to improve the management of building facility. It's about doing better with technology, using it as a means to end, and it's important to consider process and people aspect to harness the full potential of smart facility management and achieve holistic solution that can support the data-driven decision, create change, and improve outcomes. So here is the 3 suggestions for improvement, which is the first one is BIM level 3, smart building, and Li-Fi. BIM level 3 represent the final level of BIM maturity, providing completed integration of tools while taking information sharing a step further. At this stage, the information model is filled with the real-time data that can be used not only in the design and construction stage, but also at the more operational stage, covering the entire life cycle of the construction asset. BIM level 3 allows all participants to work on the same model, which drastically reduces the risk of information conflicts. The construction process is fully interconnected from design to construction management, allowing material waste and delivery time to be minimized while maintaining and improving the quality of the final product. The development of the entire process is based on the complete standard of the different phase and content. OpenBIM is a fundamental here. The future lead to a maximum between all the disciplines involved in the different phase, but the constraint defined by the property files are not present. Another key requirement for delivering BIM level 3 project is the use of IFC, which is an industry basic class open file format and is not proprietary, therefore not controlled by a single vendor. The idea is that IFC models can be easily exchanged between different software without having compatibility problem. They aim to solve the current challenge when exchanging data between stakeholders. Their aim has usually shareable nature, and this kind of collected data can be used to provide informational assets that are associated with grid and smart city. Perfection and high level efficiency is enabled across the entire locality. Next, the recommendation for improvement: smart building. Smart building can be considered as a building that uses technology, hardware, and software as a means to operate more effectively and efficiently. These include anything that can improve the productivity of building occupants to analytic features that help building run environmentally. Smart buildings are on the rise worldwide, with a 2019 report by a Johnson Control finding that nearly 2/3 of organizations worldwide plan to increase their investment in smart building technology. Moving forward, this commitment to a smart building technology is reflected in the growing market size, which is predicted to grow fivefold by 2028. A study by InfoGrid shows how smart building technology can have a significant impact on the occupant, in this case with a reference to the air quality of the building and a back to the office after the pandemic. The study found that of the worker questioned, nearly 60% said they would feel more comfortable returning to work in indoor air quality was monitored and tracked. For example, Smart Office in Amsterdam, Netherlands, and Capital Tower in Singapore use a smart building technology to adapt building operation to employee needs and increase employer satisfaction and productivity. Occupants to this building can reserve available office space, have seamless access to location information, and personalized comfort building. Building manager can handle maintenance and sanitation requests and obtain optimal space and energy efficiency. Malaysia can make neighboring country as a role model to make a better practice smart building. VR software will help you visualize an architect plan, while AR will allow you to walk through a half-finished build and see how it will look once it's completed, or at a more advanced stage by adding a visual representative to what already there. In the content of FM, AR is currently the most useful and practical software application. Next, we're going forward to recommendation for improvement. The third one is Li-Fi. Li-Fi is a two-way wireless system that transmits data via LED or infrared light. It was first introduced in 2011, and unlike Wi-Fi, which used radio frequency, Li-Fi technology only required a light source with a chip to transmit internet signal via light wave. This is a remarkable advance over to the wireless network. Li-Fi doubles the speed and bandwidth of Wi-Fi, 3G and 4G. The latter has a limited capacity and become stuttered when the number of surfing users increase, causing them to crash, reducing speed and even disturbing the connection. With Li-Fi, however, it's a band frequency of 200,000 GHz compared to Wi-Fi maximum 5 GHz. It's 100 times faster and can transmit more information per second. A study 2017 by the University of Eindhoven obtained a download rate by 42.8 Gbit with infrared light with a radius of 2.5 meters, when the best Wi-Fi barely reached 300 megabytes. Li-Fi technology has signals that are much more secure than common Wi-Fi, and hence they cannot get intercepted from the places that are outside the building.